So without further ado, I've got a special guest to introduce our special guest. Brian Urlacher is here today. He's actually going to introduce our speaker.
Yeah. I'm the old Brian Urlacher, the one that was bald before he found hair. Restore. All right. Good to see everyone today, and it's my very special pleasure to introduce someone that was once in the seats that you guys are sitting in a few years ago. Fang-Ju Lin is a graduate of our program, 2013, her PhD, and she has since had a number of adventures through in the first few stages of her career. One was that she went and worked at Farm Merit on the East Coast. Actually worked with Caitlin, who was a speaker just earlier this year, right? In February or so. And so Fang-Ju got experience working in consulting, but her long-term plan was to get back to Taiwan and to go into academia, which she did very successfully. And along with her husband, KC, she's a professor at National Taiwan University. I was fortunate enough to be a guest of hers just 3 years ago, 2016 was it? Yeah, and a wonderful host there. If you ever get a chance to go to Taiwan, amazing place. And so Fang-Ju has been an assistant professor there for 4.5 years now, and so she's coming up on that point in which you're like looking at tenure. And so, are you going to be giving us an overview of some of the work that you've been doing in the past, several years on real-world evidence, comparative effectiveness research? So, please join me in welcoming Fang-Ju.
Good afternoon. Thank you for having me today. Thank you, Tal and Simon, for inviting me. So it's actually a very touching moment to me because I've left Chicago for about 6 years, and it's good to come back. And it's actually my first time to come back to the States and to Chicago and see a lot of different changes in this building in Chicago, but see a lot of familiar faces. And when Tal and Simon asked me to kind of talk about doing the seminar, I began to think what I could tell the faculty and students here. I think that because this is a mix of the audience here, so maybe I would just, for some of you may know real-world evidence very well. I talked to a few graduate students in the morning. Many of them are in the 3rd grade or 4th grade. So I believe that the program has trained you well, a lot of pharmacoepi stuff, but maybe there are some still newcoming students. And so I will begin with introducing, maybe briefly talking about what I do at NTU, and briefly discuss talking about the real evidence, how I use the real database in Taiwan to generate real evidence, and how that works or that helps in terms of clinical and also the regulatory decision making. And then maybe at the end, give 1 or 2 examples that I have been doing or ongoing or recently do. I'll take 1 or 2 examples to kind of like illustrate what my work is most about. So as Simon just mentioned, I got my kind of journey. This is my kind of journey. I graduated in 2013, and now assistant professor at NTU in Graduate Institute of Clinical Pharmacy and School of Pharmacy. And just last month, I have assigned a different duty to become the deputy director of Department of Pharmacy at NTU Hospital, and also actively involved in the East for Taiwan chapter during the past 1 or 2 years. So if you have any question about the environment in Taiwan, being academia faculty in Taiwan, or not really just not in Taiwan, but also in overall being a faculty, they can let me know, and I will be glad to talk to you after this seminar and share with you my experience and thoughts as well. Okay, so as I mentioned, I'm going to mainly talk about the research part. As most of faculty do, we do research, teaching, service, and today's talk I'm going to focus more on the research part, and also talk about the real-world evidence, real database in Taiwan. So As Simon just mentioned, I think that the real-world data and the real-world evidence, they are buzzwords over the past few years. Actually, the concept is not new. So we know that real-world data are data related to patients' health status or the delivery of health care, and from the observations of routine clinical practice, and it can be collected through prospectively collected data or retrospectively collected data. And we know that there are several different kind of real-world data sources, such as the electronic health records, a claims database, which I think many of you are familiar with, and also the product and disease registry. And also in the past few years, there's more commonly like the patient-generated data through the mobile device or the health app. These are all routinely collected data that's collecting the patient's health status and other like delivery of healthcare information in the real-world settings. And those that the evidence can generate from the real-world data are called real-world evidence. And the real-world evidence are regarding the use and potential risk and benefits of the drugs, not just drugs, but also the medical device by analyzing the real-world data. And I also think that you probably know already that so real-world database, real-world evidence are mostly coming from the observational studies. So when we quote the real world, you're actually not saying that the clinical trials are not real world because it's still real. It's a real world. But the concept is that that's as opposed to the clinical trials, which we have the more controlled environment, which we highly select the patients, or we want to make sure that every patient to take their drug, they have their good adherence of their medications. And also that the patient selection process, that the real-world evidence, real-world database, we include more heterogeneous populations, which we don't, like clinical trials, maybe we exclude patients who are really sick, really old, who are pregnant, who are children. So real-world data is that we just like be very conclusively, we just inclusive to include all the data we have and try to generate the evidence we have in terms of the medication outcomes. So this is just kind of like the New England Journal of Medicine. I bet many of you may have read this paper. It's talking about what it is and what it can tell us. So this, as what I mentioned, the real evidence can give a lot of information, can inform therapeutic development, outcomes of patient care, how to improve the quality of our health care. And also, many people are familiar with pharmacoepi. We want to know the safety after the drug has been marketed. So the safety surveillance and also whether the drug actually works and works in different kind of patients is the effectiveness. We want to know about the outcomes of the medications. So that's what a real-world evidence like most focusing about and most will be well known about. So this is the 2019 ACE4, like they have the survey and come out with the top 10 HEOR trains. And you can see that actually I say the buzzwords of real-world evidence because this is the this is as a third as a trade, HEOR trade. And if you can see the sixth one is actually big data. So big data is also, now we have our, a lot of data that are really kind of huge enough to kind of, we really have to clean up data to analyze it or to get something out of it. So the sixth one, big data, is also related to our real world database as well, the concept. So why real-world evidence is important? And one of the main reasons is because of the 21st Century Cure Act, which was signed into law in 2016. And the law was planned to help to accelerate the medical products development and bring new innovations so that patients can get their medications as soon as possible. So the FDA started to look at real evidence more and try to see if they can get something out of it to kind of the evidence that can show that medication can be really effective in some of the therapeutic area which the clinical trials may be lacking. So as you know, that real-world database and real-world evidence you can use to monitoring post-marketing safety, and it can also use to support coverage decisions, and also can help with the clinical professional to know how to treat their patients better. And so these are all kind of important application of the real-world evidence. But if we have the real-world evidence, we still not all the real database can be analyzed right away. So we have usually some of the database we have to process that. Sometimes like you have to do chart review, data abstraction. I don't know how many of you may have the privilege of like abstracting the data from the EHR. So that's actually a tedious work, a lot of work on that. So. But for some of the data, we might still have to do that unless you may have the, I mean, in the future, like a natural language processing to kind of convert the unstructured data into the structured data. But what we care about real-world data is that we still care about their quality, the integrity, and the transparency, generalizability, timeless, and a lot of different elements and characteristics of the real-world database. And most important of all, we want the data to become real-world evidence which can inform about the clinical decision-making and the regulatory decision-making. And before I jump into the real-world database, I want to kind of briefly introduce the real-world database in Taiwan. And before I do that, maybe I just briefly introduce about Taiwan. So Taiwan is a small country that located in East Asia. The area is not large. So it's probably around the 62% size of the Michigan Lake. So there are 23.6 million of population. And actually the healthcare spending is actually pretty affordable in Taiwan. So the GDP is about 6.2% like we spend in the healthcare. So as you may know, Taiwan is actually pretty well known about its national health insurance program. So it's established since 1995. And it's a compulsory social insurance program that you require all the citizens and even foreign nationals living in Taiwan to kind of enroll in the national NHI. I would maybe use the acronym pretty much a lot of times today. Just the NHI, National Health Insurance Program, all the citizens are required. So the coverage rate is more than 99.9%. So it's a wide coverage. It covers not only the Western medicine, but also the dental care, and also the traditional Chinese medicine. So, and the premium and payment are affordable. And sometimes we would joke and say that it's an environment very good for the patients, but not for the health professionals, because then you have to kind of restrain the total budget expenditure, and patients are paying not really high premium and co-payment. So the healthcare professionals are not given enough or even the comparable salaries compared to other countries. But anyway, so this is the environment. The whole system can make Taiwan as a good environment for the patients and affordable healthcare. And also the drugs represent 25% of the total expenditure in Taiwan. Okay. So, and as many of you may know, these are the common sources of real-world database. And I want to talk more about the claims database. And since we have the national NHI program, National Health Insurance Program, so actually the claims data, the reimbursement claims actually we compose of the claims database in Taiwan. So, so we call it Taiwan's NHIRD. So you might have, if you look at many of the Taiwan's real-world database analysis, maybe you will see like the NHIRD. This is the claims database, national claims database in Taiwan. So the claims database, since it covers more than 99% of the population in Taiwan, is a very comprehensive claims database. Maybe in the later slides, I think in the later slide, I will briefly discuss about the difference, like the compared to other real-world database. There's still kind of big critique about a lot of people because of the administrative purpose and the administrative characteristics. And besides the claims database, I think it's about over 90% of hospital, I think all the hospitals have the electronic health records right now, but maybe some of clinics may not have the CPOE or electronic health records. So the EHR is also very commonly used real-world data in Taiwan. And we also have some national registries, a National Cancer Registry or National Stroke Registry, we have that. And sometimes that some of the investigators will come up with, we'll work together to come up with the disease registry. I'm involved in the lipid registry, which 14 of the hospitals collaborate together to follow the patients, and we have the lipid registry database. And we also have the national survey database. For example, the survey database we have, as US, we have the National Health Interview Survey, and we also have a special population survey, a survey about the whole population or from the specific populations. So we also use the survey database, some are national, and also we get the birth registry and death registry. So we use death registry a lot because we want to make sure that we capture all the deaths, all the different causes of death from the database. So a good point of the NHRD is that we can actually link the NHRD, the national NHRD, to a lot of different databases. And it is because, like in Taiwan, we are fortunate to have every citizen or every foreigner have a unique ID number. So we can use that unique ID number to do the direct or the exact linking. We don't have to do probabilistic linkage to analyze data. So that's the beauty of the patient ID. We can link the data, link the NHRD claims database to a lot of different registry of different databases. So we also have the national statistic and also the data that collected from a mobile device or other apps. So this is just what I just mentioned. And besides the registry, NHRD can be collected to other survey or registry database. We can also have collect to the healthcare providers information and also the hospital information. So if you want to study whether certain hospital may have the influence on the outcomes, you can do that as well. And because I mentioned that if you have the unique patient ID, you can also link the hospital EHR to the NHRD. So the second example I'm going to share, research example I'm going to share is actually we link the National Health and NTU Hospital EHR to the NHRD because we know that the hospital EHR has a lot of clinical information in the lab results. So by doing that, we're able to study a lot of different questions that cannot be studied if we only have the NHRD. So utilization of real-world database and real evidence is that it can be used in improving patient care, in use in the clinical guidelines and care quality improvement, and also care used for the regulatory decision making. So you probably have seen this paper. So this paper is talking about how real-world evidence can be used for regulatory purpose. So usually we would talk more about, we would apply more or utilize real-world evidence more on the safety monitoring or stability part, but it can also be used to confirm if the drug is effective in the real-world setting. But also, it becomes more and more common, maybe not that common enough, but more common to the real-world evidence can be used to expand the label, such as the reason Pfizer has the drug that can be approved for men breast cancer is the example of that, using the real-world evidence to kind of show that the drugs can be used which is not a common situation, the men breast cancer, but FDA just have the label change or the revision expansion on that drug to be able to to cover the special population just based on the real-world evidence. And also maybe in Taiwan it's more also, I'm not sure, maybe US may be less an issue, but in Taiwan we use real-world evidence a lot to help with the reimbursement and coverage decisions. Maybe not exactly on coverage that, but for preparing the materials for reimbursement, we will use a lot of real-world evidence in their preparation in the HTA, Health Technology Assessment. Okay, so this is a busy slide. Just want to kind of give a more detailed examples about how real-world evidence can be used to improve the healthcare and to enhance the health policy decisions in Taiwan. So as we know that healthcare providers may use the RWE to come up with the practice guideline and to put that into the CDSS to improve patients' care. And besides that, the TFDA has the similar work function as the FDA. It will apply the real-world evidence in their pre-approval decisions as well as the post-approval decisions. And this one I just mentioned, and the plus side means that the relative importance of real-world evidence for decision making in each aspect. And I want to put more emphasis, I will spend more time on the one I mentioned, that the National Health Insurance Administration. So this is the National Insurance Program, and we use the real evidence to help with the health technology assessment. I don't know how many people, whether the students here are familiar with the health technology assessment. Okay, good. So I think that this is actually the knowledge concept is not that I think you all know, but maybe not. I think that HTA part I realize or understand more after I get back. I get out of the school, and even doing my previous consulting experience, maybe focus more on HEOR work. I didn't actually have a lot of exposure to the health technology assessment. But actually, that's an important thing, at least in Taiwan, because as you know that because an NHI of our program has to, because that's the National Health Insurance Program, so we have decided how many drugs and what are the drugs that we are going to reimburse. So we use the health technology assessment to kind of systematically evaluate not just from the very beginning basic, the drug quality, the safety, efficacy, and also we review the cost effectiveness and budget impact. So budget impact is I think that when I was a graduate student, I didn't really know about budget impact that much. Maybe we talked a lot about cost effective analysis, but maybe not budget impact. So, I mean, we talked about that, but didn't know exactly how we're going to use that. So budget impact, for example, budget impact analysis is trying to let the decision makers know if we are going to reimburse the drug, how much would that cost? So what extra money would we cost? So for preparing for whether that new technology is affordable. So preparing for the budget impact analysis, we will need the epi data to know the disease burden, to know the current treatment patterns, and know something like the outcomes that are related to the cost estimation. So we actually use the real-world evidence a lot in terms of getting the parameters for the budget impact analysis and also the cost-effective modeling. And as a school, as a faculty, I think that although it looks like that will be related to the industry part, actually in Taiwan as a faculty who has expertise in pharmacoeconomics and pharmacoepi, we actually can be involved in the whole HTA process in different aspects. For example, like usually the industry will submit the dossier for the HTA dossier, and how to come up with dossier, we need the data, right? So we would just sometimes like industry will work with the academia, especially one of reason is because the NHIRD I just mentioned is actually limited to the use in academia. So if you are in industry, you can only use that if they collaborate with the universities. So for preparing the submission, sometimes we would work in the industry to come up with the cost-effective analysis estimates or the budget impact analysis estimates. And the Center for Drug Regulation, they are people who will review the submission by the manufacturers, and then they will, when they review, they may consult the clinical aspect and pharmacoeconomic aspect as well. And you can, and as experts in HTA or health economics, you can also be part. You can also sit on the advisory meeting or PBRS joint committee to make the final decision about whether the drug can be reimbursed or not. Okay, so I just want to make sure how much time I have. So in terms of my research, I still focusing on more of the clinical effectiveness and safety part, which the real-world evidence part, or called the comparative effectiveness research or pharmacoepi part. And I do some of the patient-reported outcome with also alumni also from the UIC PSOP as well, Margaret, Dr. Fang-Ju Lin. And we did a EQ50-5L evaluation study in Taiwan. I helped him to do analysis. And I'm currently not doing a lot of patient-reported outcomes, but I hope I can do more in the future. And economic consideration, we do some of the cost analysis sometimes that we to evaluate the hospital pharmacies to whether it's good to invest the pharmacy service in certain therapeutic areas, whether it's good to invest our pharmacies. And also, as mentioned in HTA, we will help sometimes work with the industry to come up with the cost-effective analysis and budget impact analysis for the new technologies. So what the database I use are mainly the Taiwan's NHRD, EHR, and also the product or disease registry. And as mentioned, I previously saying that I want to briefly talk about the comparison of different real-world database sources in Taiwan, because you may think that, okay, we have a really good national claims database, and that's good. But sometimes but a lot of times because the claims database, we don't have the lab results, we don't have vital signs, and the claims database are not enough to capture like many of the clinical severity data. So it's kind of big critique. And another thing is that NHRD is frequently be critiqued because it's still a claims database. So as many other claims databases, you may have the issue of undercoding or overcoding. Undercoding means that for our patient, we only have 3 fields for filling in the diagnosis. So if you have more than 3 diagnoses, then you will be, for some of comorbidities, you will be under-captured. You will not be captured. And so for overcoding, let me give an example. So if a physician wants to order a HbA1c for the patient who doesn't have or suspected to have diabetes, maybe he would just code it diabetes, which is a kind of like overcoding. So we might have to, maybe that would be sometimes in the issue in the US as well. So we have to make sure the specificity of the diagnosis and how we're going to define that patients having the diabetes, for example, to make sure that we are analyzing the data properly. So these are the NHRD, the pros and cons. For electronic health records, I don't know how many of you in this room usually work on the electronic health records. There's a lot of information, but then a lot of like lab data, even the structured data like lab data, you sometimes require a lot of like resource to clean the data, because the lab may have different panels, and different panels may have different units, and some of the data like greater than or less than, it cannot be analyzed directly. So even for the healthcare, or even for the EHR data, sometimes it seems like a structured data, but you still have to put a lot of effort to kind of clean out the data. And not mention about the unstructured data. You might have to like human resource to kind of abstract the data from the EHR. But a good thing, another good thing besides the abundant health information is that EHR is good to study the in-hospital or inpatient outcomes, which may not be that complete in the claims database. But the problem of EHR is that the patient may come and go, and especially in Taiwan, we have so convenient and so affordable healthcare, so patient may have like doctor shopping. If they come to this hospital and then go to the other hospital, So we may have a problem of the patient attrition, and it may not be representative if we only involve only one hospital. For example, like the examples I'm going to give later is about the cardiovascular disease. So most of you know that in cardiovascular disease or CV, there is the MACE, major cardiovascular adverse outcomes are the outcomes that we measure a lot. So for a patient who has MI, maybe although he's following in this hospital, but if he suddenly have MI, maybe he would not be sent to that hospital which he usually go to. He was sent to the nearest hospital that to kind of treat the patients. So in that case, if we are using the EHR, we might lose some of the patient. Maybe we cannot capture some of the events in that case. And we also have the registry data, and registry data is some of the registry data is kind of like managed or operated by the government or some of the organization, and some of them registries are kind of maintained and operated by the PIs. So you might have to kind of have a consortium and really a lot of resources to kind of maintain and keep the patient follow-up through the regular time if that's one of the purpose. So operational maintenance issue will be enough. It will be a big issue, and also how to control the data quality, the data recorded by the physician assistant and everything, and also whether that will be representative and to kind of represent the whole population. So sometimes, like for my research, I would depends on the research question and the data availability to kind of choose from all the sources. So this is a kind of like slide, kind of summarizing the projects that I've been at least completing, or most of them are completed projects that I've been working on over the past 1 to 3 years. So my research focus on more of cardiovascular and COPD and also diabetes. And many of them are CER, comparative effectiveness research, and some of them are kind of predicting the patient's outcome or the cost-effectiveness analysis. And today I'm going to focus more on the first and the second example about the research I have done, and to give you kind of a very brief idea about it. So the first example is a study that is completed last year and just published in July. So that's this topic is related to the comparative cardiovascular safety of fibusostate and allopurinol. And actually I post this picture because it's interesting to me, because that after the being accepted, I was asked to kind of have a video taken about explaining my research. Actually, it's my first experience on that, so it's really an interesting experience to me to kind of put my videos on the YouTube. I'm not a YouTuber, so it's kind of have to find a small room in the library to kind of talk about the research by myself. But that's an interesting one. So I'm going to kind of briefly walk you through the study. So as many of you may know, are familiar with allopurinol. It's an anti-hyperuricemia drug. Fibusostate is a newer drug that been approved in the past 9 years or so. So it's usually indicated for patients who, because it's more effective and it's a newer drug, it costs more. So usually indicated for patients who have inadequate response or intolerant to the allopurinol. So allopurinol, it can treat gout and lower the uric acid by inhibiting the xanthine oxidase. And by reducing the uric acid, we can minimize or reduce the symptoms from the gout. So you can see the daily dose here. Allopurinol dose usually is about 300 milligram, and as later, I'm going to show later, in Taiwan we are not actually treating patients with that high dose, 300 milligram. And the fibusostate usual dose is between 40 to 80. So this is kind of a summary for how how we use the uric lowering therapy and overall in the global. So the goal is to lower the serum uric acid to lower than 6 milligram per deciliter. But different guidelines, different countries may have different guidelines. But the the main concept is to use the sensing oxidase inhibitors first. And if patients are not intolerant or ineffective enough, maybe patients will add the uricosuric agent. So uricosuric agents help to help the uric acid to excrete in the urine. And maybe you can also use combination. But in Taiwan, we have the guidelines, so there's no very conclusive recommendation about what should be used first. So the Febusostate was approved in the States in 2009, and it started approved in Taiwan until 2011, and it's reversed by the NHI in 2012. So why is Febusostate also an important drug in Taiwan is because allopurinol is an important drug that is a well-known drug that may cause the severe cutaneous adverse reaction. And this is the rate of the allopurinol-induced scar. And if the allopurinol-induced scar happens, especially the Stevens-Johnson syndrome and PAN, the toxic epidermal necrolysis, the mortality can be up to 25%. And if a patient has the HLA-B, this 5801 genotype, then they will dramatically increase the risk of allopurinol-related Stevens-Johnson syndrome, which can be very life-threatening. And also the frequency of this genotype is high, much higher in the Han Chinese than the Caucasians. So in patients who may be intolerant to allopurinol, Febusostate is a better option. But there's some issues, safety issues related to Febusostate. The previous clinical trials shows that there's a higher rate of heart-related problems in the Febusostate users compared to allopurinol. And also, the FDA analyzed the adverse event reporting system and found out that Febusostate actually are also related to a cardio, not just the cardio heart-related problem, but also can increase the thromboembolic events. And because of that, US FDA has required the industry, the pharmaceutical company to have the clinical trials focusing on the safety. So in these CARES trials, which the preliminary data come out in 2017 and published in 2019, the primary endpoint is the composite CV endpoint, and the secondary endpoint include the CV death and all-cause death. And these trials actually requested by the USDA, but unfortunately they found that Febusostate will increase the CV death and all-cause death. And that actually makes the FDA to release the drug safety communication in 2017. So this is the DSC. So why do we want to do this study? It's because that although there has been previous clinical trials and also the CARES trial has kind of like showing the safety warning of this the Febusostate, we still want to know whether in the real world practice, whether the Febusostate is associated with a higher risk of cardiovascular events. And we also, because the reimbursement environment and the utilization of XOI, the drugs are different, we want to know whether compared to allopurinol is it's a good alternative, and whether there's any dose response effect. So we conducted a cohort study to use the NHIRD and also the National Death Registry. So National Death Registry enabled us to capture all the deaths, to make sure that the patients not just disenrolled from the insurance, they actually were dead. So we have the inclusion-exclusion criteria to ask the patients to be a new user of XOI. They cannot use the Febusostate or allopurinol before. And also we exclude the patients who are having, they may use the Febusostate or allopurinol for the hepatology malignancy diagnosis, because usually when patients are receiving the cancer therapy, they may cause in the tumor lysis syndrome, which will use the XOI to reduce the serum uric acid level. So we conducted a PS, matching. We run the PS model, and these are the covariates included in the model. I'm not going to go through a lot of details, but just the characteristic, patient's basic characteristic, and also the comorbidities and also the baseline medications. And these are the study endpoints that we want to study. We want to have a comprehensive assessment of the cardiovascular events. So not just MACE, but we also study the VTE, and those are the CV-related hospitalization may cause due to these different causes, and also CV death and all-cause mortality. I'm not going to talk into a lot of details in this slide, but just want to mention that in the main analysis, we use the adjudicated approach, and this is how we define the discontinuation or switching or censoring for the follow-up. So for data analysis after the matching, for the PS matching, I'm not going to go to a lot of details, but we do the PS matching model, and we also match the patients by other co-batch, which I'm going to show maybe in the following few slides, and run the Cox model to estimate the hazard ratio associated with the febusostate compared to allopurinol. And in the sensitivity analysis, instead we use the intention to treat and related approach, and we revise the outcome a little bit to make sure that our study results are robust regardless of the different outcome definition and inclusion criteria. And we also run a subgroup analysis to make sure that the effect of the febusostate compared to allopurinol are consistent or throughout all the subgroup populations. And besides, I mentioned that we also do the dose response analysis. So what we do is that among the febusostate and allopurinol users, we separate them out. And then for each of the patients, we calculate their average dose every 30 days after the index date, so that we have the time-dependent dose over the time. And we want to see whether having a higher dose are associated with a higher risk of the cardiovascular events. So we use the DDD defined daily dose to categorize the different dose and want to examine the dose response relationship. So this is the flow chart that we get. After applying the inclusion-exclusion criteria, we identified around 56,000 of febusostate users and about 4 times of the allopurinol users. And we matched by not just propensity score, but also matched by the history of the uricuric agent use and the renal impairment, and also the index date before after 2014, because based on our National Health Insurance Reimbursement Scheme, we have the different criteria for reimbursing febusostate. So that's why we want to kind of match the patients more closely through this to make sure that allopurinol and febusostate use are kind of pretty similar in terms of their medication history. So after matching, we got each group around 44,000 of patients. And these are the baseline characteristics. I'm not going to go into a lot of details. So just want to mention that before matching, the febusostate users, because that's a new drug, and as expected, the febusostate users having more comorbidities and use more correlated drugs. Okay. So we also found out that the febusostate has a lower discontinuation rates and lower rate of switching to other drugs, which makes sense. And in our adjudicated analytic approach, we have the median follow-up about 120 days for febusostate and 85 days for allopurinol. For intention to treat analytic approach, we use this approach in a sensitivity analysis. So this is the main results. So we found that there's no significant difference in terms of risk associated related to the MACE and VTE, but we do found that the febusostate users has a higher chance, high risk of heart failure, hospitalization, atrial fibrillation, AFib hospitalization, and also CV death. So the risk is 20% higher than allopurinol users. And this is the sensitivity analysis focusing more on the heart failure hospitalization, because when we look at we found that the heart failure is the endpoint that consistently, the result is consistent throughout all the sensitivity analysis and subgroup analysis. And in terms of daily dose, we actually found that febusostate users have usually kind of normal dose, But for allopurinol, we found that the dose that we use in Taiwanese population are much lower than we expected. But when we do compare the different doses among the Fabusis users, we found the dose response relationship. We found that the patients who use a higher dose actually having a higher risk of heart failure hospitalization and atrial fibrillation hospitalization, which is kind of consistent to what we expected. So higher dose may cause a higher risk of events. Okay, so this is a slide that kind of compare our main findings with the one that the trials, the CARE trials that you previously mentioned. So in the CARE trial, we found that the CV death is higher, and we found the same thing. And we also found that the heart failure hospitalization, the rate is higher, and this was not revealed in the previous CARE trial. However, so far there's no kind of known mechanism explaining why Fabusis have a higher risk of cardiovascular events. So, we know that uric acid actually, although too high is not good. Actually, uric acid is inherent antioxidant, but when the uric acid is too high, it may increase the blood pressure, and it can also cause the vascular smooth muscle cell perforation, which may not good to the patients. And actually, the xanthine oxidase inhibitors, they can lower the uric acid, and also they can generate, they can lower the ROS that can be damaged to the endothelial cell and the endocrine. So it has been, previous studies have shown that allopurinol as a xanthine oxidase, previous studies have shown that allopurinol can have the antioxidant effect. However, we know that uric acid too high is not good, but why Fabusis is associated with a higher risk? We started to think about whether that's because it's too effective. Fabusis is too effective and lower to the uric acid too low, so that maybe it can have an opposite effect. So usually we will try to keep our patients' uric acid less than 6, but what happens if uric acid is too low? So we started to review the literature because there's no known mechanism explaining why Fabusis will be more cardiotoxic. So we review the literature and see that actually there's a U-shape has been reported, a U-shape association between uric acid and outcomes. So if we lower the uric acid to maybe less than 4, actually the cardiovascular risk will increase. That probably may explain why Fabusis, being a more active, more effective drug, can actually cause more cardiovascular outcomes. But the problem of these studies is that they only use 1 point of the uric acid level at the time to predict the CV outcome 10 years later. So actually there's not much enough information or the evidence to show whether that's surely a U-shaped association between uric acid and outcomes. And that's another study which kind of like try to correlate the uric acid level to the 1-year CV outcomes, and also find the same thing. If the highest risk is the patients who really have a high uric acid, but if you really lower the patient's uric acid less than 4, that also increases the patient's risk as well. But similarly, this is kind of using 1 point uric acid at event time. So what we are thinking now is that since that in our population, about 24% of patients are using 80 milligram of Fabusis, and in the previous trial, we know that with the 80 milligram per day dose, there's 20% of patients may really get their serum uric acid less than 4. And in allopurinol, we know, as mentioned, that there's only very few patients with using this dose. The mean dose is about only one third of the defined daily dose. So we probably kind of like speculate that they could be that Fabusis lower the uric acid to too low, so that they increase the cardiovascular events. And also because we found that the dose response effect of Fabusis on the outcome that kind of support our the hypothesis. So there, after this study, there may remain other questions that can, me and my team are going to kind of like do more analysis to solve the issues that what's the main cause of Fabusis-related cardiovascular events. So it can be because of Fabusis itself, maybe that there's due to some mechanism that causing more cardiovascular events, and maybe because they lower the uric acid. So maybe patients shouldn't be having low uric acid. And another kind of debate over the past literature is that because in the CARE trial, in our trial, we are using allopurinol as a comparator. And as mentioned, allopurinol is known as an antioxidant, not just lowering the uric acid, but it actually can act as an antioxidant. So maybe that's a problem using allopurinol as a comparator. Maybe because not because Fabusis is bad, maybe because allopurinol is good. So when compared to allopurinol, Fabusis becomes bad, looks bad. But so that's the problem. That maybe we can use other drugs as a comparator in the future analysis to show why the Fabusis is surely associated with cardiovascular events. Okay. So I think that probably time. Okay. So this is kind of like the strength and limitation of this study, but I think that that I won't go into a lot of details. And just want to mention that this February that the FDA put a box warning on the Fabusis day-related cardiovascular events just based on the CARES trial results. And then we expect that more evidence will be coming up to kind of know about these issues. Okay. So the second example, I'm not going to a lot of details. I choose to be a CVD research so that cannot be a kind of different jump from the first one. But I think that that's just examples that maybe using the to link the EHR to the national NHRG to kind of know whether using the statins is good for primary prevention in the elderly, because there hasn't been a lot of studies or conclusive evidence on that. But I think that due to time, I didn't actually plan to complete all the 2 studies because that's too much, but I just put it there in case that, okay, I talk really fast and then I will have a lot of time. So don't worry, if I haven't been able to finish that, that's totally fine. So I'm going to jump to the very end of the slides. Okay. So what I've been talking is about the studies that have been completed during the past 1 or 2 years. And in the future, I will continue to work on the comparative effectiveness research and also the machine learning for predicting the patient's disease outcomes and applying the real evidence into pharmaceutical policy, evaluative pharmacy service, and do more analysis regarding the drug-drug interactions, and also work on the drug integration. We are working on the project kind of like integrate different EHR in the different hospitals to have a common data model in distributed data network, and also focusing on the studies on the utilization and cost in drug safety. And I think that's all I have. And I want to thank all the collaborators and my students and the research assistant for supporting me and working with me over the past few years. And thank you.